Hi students, this is Julie. I'm going to put together a couple of videos for you today. The first one in this series will go through sort of the process of graphing a linear inequality. And as I go through this problem, I'll explain both the steps that we do and kind of the reasoning behind it. So why we do the things we do when we graph a linear inequality. So first thing that I want to do is I want to look at an example of a linear inequality here and talk about what we mean when we say linear inequality. So if you look at this mathematical expression here, y is less than or equal to 2x plus 2, it looks an awful lot like the slope-intercept form equations that we've been graphing previous to this. So we've got y by itself on one side of the expression here. We have a number multiplied by x, and then something added or subtracted from the x term, which is what we see, or what we talked about seeing in slope-intercept form. And so really the only difference between this and what we have been doing up until now is this less than or equal to sign. So in the other problems that we've done, we've had an equal sign there. Now we have a less than or equal sign. And so it's going to change the way we express our solutions a little bit. But the general process, or the beginning of the process for graphing the solutions to this linear inequality, will be very similar. So that's really the only difference between a linear equation and a linear inequality. So how do I go about graphing the solutions to this problem? So first, I'm going to think about this as though it were a linear equation. So I'm going to imagine that I actually just have y equals 2x plus 2. And I'm going to start to graph this as though this were just a regular line, just like we've been doing. And so because this is in slope-intercept form, I can see that the 2 at the end here is the y-intercept. And I know that when I go to mark this on my graph, that's where I start. So I'm going to mark a point at 2 on the y-intercept. Put that over there. And then I can also see that the number in front of the x is 2. That should be the slope. I'm going to think of it as 2 over 1. And I can use the slope then to go over to the graph, and I can find another point that would be on this graph. Since the slope is 2 over 1, that tells me that the next point to the right is going to be up 2 spaces and 1 space to the right. I can mark a point right there. And I can keep going. I know that there's going to be another point up 1 space over 1 space. I can do that all the way across the graph here. And we also talked about how 2 over 1 is the same thing as negative 2 over negative 1. So I could also go back to my original point, go down 2 spaces, and go 2 spaces to the left. Fill in a mark there. Down 2 spaces, 1 space to the left. Keep doing that just to kind of mark some guidelines here kind of on the graph as I go across. Okay, so now I've got a pretty good idea of where that line is. And before I get to actually connecting these dots and filling this in, I need to think about one other thing, and this is where the inequality part comes into play. So I'm going to think about the fact that this is a less than or equal to sign, not an equal to sign. And so one thing I would think about is that I want part of this. It's saying that y can be less than or equal to 2x plus 2. And so everything that lines up with these dots that I just put on the graph would represent points where y is equal to 2x plus 2. So these are part of the solution, and if I connect these together, that would sort of take into account, I have to do this kind of carefully here, that there's points in between here that have fractional values that are also solutions to this inequality. So in other words, points with fractional coordinates where y would be equal to 2x plus 1. Now, I also have to think about the fact that there's a less than symbol here. And so I also want to mark points where y is less than 2x plus 2. Okay, so say for example, at this point here, the first point that I marked, which was the y-intercept, this is where x is equal to 0. And we figured out, or we know from the equation, that if x equals 0, that y equals 2. Okay, and if we plug back into the equation, we get that because, well, actually I'm going to leave the symbol out for right now, but if I did 2 times 0 plus 2, 2 times 0 is just 0, and 0 plus 2 is 2. Now, here's where I'm going to go back to this less than or equal to part. What I've marked on the graph is where y is equal to 2, but this is telling me that y could also be less than 2. And so that means that when x is equal to 0, y could be 2, but it could also be 1. It could be 1.5. It could be -5. It could be any number that is less than 2. And so actually what's going to happen is that I could sort of fill in this whole line of points where y is less than 2. And that's going to be true for every one of these points that I just marked on here. And it's actually also going to be true for every one of these in-between points on the graph. And so what we can see is that what we end up doing is kind of shading in one whole section or one whole side of the graph, in this case underneath the line. And I'm just doing this kind of using stripes, but really what I should be showing is that this is entirely shaded in. There should not be any gaps here. But just because that takes a lot of time and ink, we often don't fill in the entire section down here. It's okay to indicate which side is shaded just by using stripes or something like that. Okay, so there's kind of a shortcut for figuring out which side of the line needs to be shaded in. And that shortcut is to use a test point. So what I'm going to look at is back over here where I'm thinking about my original problem. After I graph the line, I figure out where the line needs to go, and I decide that it's either going to be, I guess I should mention here, in this case it was a solid line because we had y as less than or equal to 2x plus 1. That's always going to happen if we have an inequality symbol that is a less than or equal to or a greater than or equal to, we're going to have a solid line. The way that we're going to show the line if we have just less than or just greater than, that means that we're not actually including the points where y is equal to whatever the right side of the equation says. We're only including the points that are less than that or greater than that. And the way we're going to indicate that is with a dotted line. It's very much like when we were doing number line problems and we used either a closed circle, which would be like the solid line, or an open circle, which would be like the dotted line on the graph. Okay, so I graph the I graph the line using the y-intercept and the slope. I know where the line needs to go. I look at the inequality symbol and I decide is the line going to be solid or dotted. And then the last thing I'm going to do is decide which side of the graph to shade. And so in this case, I was able to sort of reason my way out that I wanted to include all the values of y's that were less than 2. Sometimes if there's negative numbers in the problem, or just depending on how the problem is set up, it's not so easy to tell which side of the graph to shade. So in that case, what I can do is I can choose a test point. And a really easy test point to use is 0, 0. And the only time this doesn't work is if my line goes right through 0, 0. in this case it doesn't, so I'm going to choose 0, 0. And what I want to look at is if x is equal to 0 and y is equal to 0, do I get a true statement with this inequality? So for this one, for example, if I do 0 is less than or equal to 2 times 0 plus 2, is that true? And if I simplify this, 0 is less than or equal to 2 times 0 is 0, plus 2 is 2. Yeah, that is true. 0 is less than or equal to 2. And what that tells me is that 0, 0 is a solution. And so 0, 0 should be in the shaded part of the graph. I should be including that in the set of my solutions. And so at the end of this, when I've graphed in my line and when I've shaded one side of the graph, everything that I've marked here is a solution to the inequality. And then I'm done. All right, so if you'd like to see a couple more examples, check out the videos that I post after this. Otherwise, go back, rewatch this one, check out the steps again, and I will see you in class. Thanks.